Hello everyone. Today I will discuss 10 problems from CSIRNet PYQ on reaction mechanism and named reactions. So let's start. So first problem is the major product formed in the following reaction. They are given this bicyclic ketone, and reduction of this bicyclic ketone it yields the alcohol. But you need to give the exact stereochemistry of this of that alcohol. So let's see. It is a bicyclic ketone. So if there is, in case of bicyclic ketone, if there is no substitution at the bridgehead position, that is here. This is the bridgehead position. If there is no substitution at the bridgehead position, then it leads to the end product. That is this product. That is hydroxyl group at the axial position. If there is a substitution at the bridgehead position, then it leads to the formation of the exo product as the major product. That is this product. This hydroxyl come at this equatorial position. Okay, so so in this example, see this bridgehead position is sterically hindered by these two methyl groups. So exo product will be formed as the major product. Okay. So here exo product is formed as the major product. Here hydride group is attacked from this way. So it will form this hydroxyl group at the equatorial position, which is exo product as a major product. So so our correct option is the option 4. So option 4 is the option correct. So the next problem is the major product formed in the following reaction is they are given this ketone and hydrazine and triethylamine as a base and methyl nitrile and at room temperature. So the reaction of this ketonic carbonyl group and with the hydrazine, it yields the hydrazone. That is C over here. O is replaced by N single bond NH2. So let's see. So here you see at the first step, it will lead to the formation of hydrazone. Then they are given this base, and that is triethylamine. This triethylamine base abstract this proton of this hydrazone proton from NH, so it leads to the NH double bond N single bond C. Here will be negative comes, and this negative abstract the proton from this protonated triethylamine to form to neutralize to become neutralized. So here it becomes C C single bond N double bond N single bond H. Okay. After that, again another mole of triethylamine abstract this base, abstract this proton, and this leads to the removal of the nitrogen. And here negative charge will be there. Okay, so this negative charge conjugated and comes here, and this bond will cleave, and due to this formation of this alkoxide ion, and here that alkene. So again, if we add there is in the system there is a protonated triethylamine, so it leads so this alkoxide will be protonated to form this alcohol. So this as the major product will be formed. So option 3 will be formed as the major product. Okay, so option 3 is the correct option. Okay, next problem is the major product formed in the following reaction is they are given this reaction. They are saying this substrate will undergo the heat will under the heat condition. What will be the major product? You need to say. Okay, let's see. here 2 plus 2 by in the 2 plus 2 cycloaddition reaction is not possible. See here the 2 pi electron and 2 pi electron, and here see in the option also they are cyclized something. There is a cyclization. There will be some cyclization, but 2 plus 2 cycloaddition is not feasible in the heating condition. So it is thermally forbidden. So it will undergo a simple in reaction. Let's see. See here, if we rearranges this substrate into this, so here you see this double bond will abstract this proton, and uh, this this bond will come here to form a double bond, and this double bond cleave to here to form the sigma bond. So here will be six-membered ring will be formed, and methyl ring with methyl substitution, and CH double bond CH2 as the major proton. So option 1 is the correct option. Next problem is the major product formed in the following reaction sequence is. They are given the plenty of reagents, that is sulfonyl chloride, sodium azide, and methanol. And second is potassium tert butoxide, which is acting as a base. And number three, there is something like hydrolysis will occur. Okay. So let's see. See here, sulfonyl chloride will convert this sulfonyl chloride will convert this carboxylic acid to the acid chloride. Here, so you see acyl chloride. And then this sodium, they are given this sodium azide. This sodium azide ion easily substitute this chloride ion to form this acyl azide. Then then there is a then it leads to the then there is a removal of this nitrogen, and it leads to the formation of this nitrogen intermediate, and from this nitrogen intermediate it leads to the formation of this isocyanate ion. Okay, like this way. Then this tert butoxide, then they are giving this potassium tert butoxide, which is acting as a base. So here you see adjacent to this carbonyl group, this hydrogen is most acidic. So it abstract this proton, and uh, so this proton abstracted. So this bond come here, and it forms this enolate type of ion. Okay, this then this O minus comes back, and double bond attack on this C carbonyl carbon, that is isocyanate carbon, and it leads to the formation of this type of amide, cyclic amide. Okay, then upon the then after the hydrolysis, uh, it will lead to the formation of this acid. So here you see the two methyl groups in this structure. Two methyl groups are in the same side. Okay. So here you see also this methyl. This is a methyl group, and this is also methyl group. These two methyl groups are in the same plane, and methyl and carboxylic acid in a group in the above the plane. So uh, it is formed as the major product. Here two methyl groups are cis to each other. So option 3 is the correct option. The correct statement about the following reaction is that they are giving this substrate, and giving this reaction condition is the photochemical condition. Okay, so see here, first step is the removal of this nitrogen. So due to the removal of this nitrogen, there will be carbon intermediate will be formed. So this carbon intermediate will be rearranged to form this type of ketene. This is a ketene. Then attack of this methanol on this ketene carbon leads to the formation of this type of ester. Okay, so option one is the correct option here. See here, they are saying the reaction proceeds through the carbon intermediate, and and A is this option. A is similar to this major product that we found. So option one is the correct option. Next problem is the major product formed in the following sequence is they are giving this allylic alcohol and reagents are MCPBA, that is metachloroperbenzoic acid, which is acting as the epoxidizing agent, and then they are giving this sodium azide and methanol, and third reagent is PPH3, that is triphenyl phosphine and methyl nitrite. So let's see. Here see, first due to the presence of this MCPBA, it will lead to the formation of this. Uh, it will lead to the formation of uh, this epoxide. Then this sodium azide as attack via the SN2 attack with the SN2 attack. So this will azide ion will attack from the uh, above the plane, and it will cleave this bond. So it will form as N3, which azide is present azide N3 is present in the above the plane, and alkoxy is present in the alkoxide ion is present in the mm, below the plane. And methanol, then they are adding this methanol. This methanol is acting as a some acid. So here, due to the presence of this methanol, it will this higher alkoxide ion um, abstract the proton from this methanol to form this alcohol. Okay, when our azide, that is N3, will be present normally present like this way, that is N triple bond N triple bond N plus single bond N minus, and it is bonded to this ring. Then they are adding this PPH3. This PPH3, that is triphenyl phosphine, will attack on this nitrogen, and this triple bond will be cleaved to form this here double bond, and this double bond come here. This triple one bond will be neutralized this nitrogen, so it will form this N double bond N single bond N negative, and here will be PPH3 plus. Okay, then this negative and positive will be collapse with each other, so it will form a cyclobutane like type of structure, that is square type of structure. Here you see N double bond N single bond N PPH3. So after that, there will be the release of nitrogen, that is N triple bond N, and here will be a cleavage like this is a cleavage type of like the Wittig type of cleavage. Here it forms this N double bond PPH3. Then after this, they are giving we they are after this there is a hydrolysis. So due to the hydrolysis, it forms this amine, that is primary amine NH2. Then due to the presence of this PPH3, this OH uh, will be converted into the labile OPPH3 positive. Then, due to the SN2 attack of this amine, it leads to the release of this PPH3 plus and O minus, that is triphenyl phosphoxide, which is formed as the major product. This is formed as the major product here. So option 2 is the correct option. Next problem is they are saying the major product A and B in the following reaction sequence are, and they are giving this uh, bi dihalide and dihalides. In the present, they are with reagents is triphenyl phosphine and sodium hydride. It gives this proton intermediate A. Then after this reaction of the with this uh, the salicylic acid and sodium hydride, it gives this product B. Okay, let's see. This is a type of Wittig type of reaction. First, PPH3. Here they are giving this uh, halides. So PPH3 will attack on this carbon, and due to this due to the attack of this PPH3 on this carbon, there will be release of this bromide ion. So it leads to the Br CH2 CH2 and PPH3 plus. Then due to the then there will be hydride ion attack on this, and hydride ion act as a base here, so it leads to the so it leads to the release of this bromide ion, and here will be alkene will be here, so CH2 double bond CH single bond PPH3. After this here is a they are giving this carbonyl compound. This is acting as this reaction is like a Wittig reaction. See here, here it is. Uh, uh, Here it is the elite triphenyl phosphonium phosphorus triphenyl phosphine elites is there. So it leads to the formation of this type of cyclobutane type of structure, that is square type of structure, and it leads to uh, the cleavage of this bond, and cleavage of this bond, and it leads to the removal of this PPH3 P, PO PPH3, and it leads to the formation of this. So here alkene will be formed here, so here alkene, then CH2 plus. Then after that, here alcohol will be there. So this lone pair of this alcohol will attack on this cation to form this cyclic structure. Then hydride will be there, where they are given this hydride. This hydride will remove this proton uh, to form this epoxide. What is this ether? So this is the product B. Okay. So the option 4 is the correct option. Next problem is, in the following reaction sequence, structure of the following products X and Y are. They are given this reaction. We need to find out the structure of X and Y. So first reaction condition is they are given this sodium ethoxide. So sodium ethoxide removes this acting as a base, so it will abstract this methyl proton. So it will due to this it leads to the formation of this CH2 minus and here NO2. And here due to this presence of this NO2, these methyl protons are acting as a acid. Okay, because NO2 has a electron withdrawing effect. So this negative ion, then this anion will attack on this carbonyl of this ester, diester, and it leads to the elimination of this ethoxide. So it leads to CH2, CO, and single bond CO2 ET. And after that, they are adding this zinc and alcohol and zinc in acetic acid. It is a Clement reduction reaction. It leads to the reduction of this uh, reduction of this nitro group into the amine. Then after that, there will be this amine will attack on this carbonyl because the carbonyl of this carbon is more reactive than the than the esters. Okay, so that is why it then here this amine amine lone pair will attack on this carbonyl only, not on this carbonyl. So it leads to the formation of the five-membered ring, and after that dehydration, it leads to this product Y. So the option one is the correct option. Okay. Next question. The major product formed in the following reaction is, they are given this uh, substrate and the reagents, and we need to find out the major product of this reaction. So first is they are given this CH2Br, that is bromide. So in the presence of the magnesium, it leads to the magnesium bromide, that is which is like uh, a Grignard reagent. So after that, they are adding this CO2. So CO2 after adding this CO2 and H3O plus or proton, it leads to the formation of this carboxylic acid, CH2 and CO2H. Okay. Then, due to the presence of this COCl2, COCl whole twice, it leads to this carboxylic acid will leads to the formation of this uh, chloride ion. Okay, and that is acyl chloride. And then this triethylamine will abstract the proton from this carbon, because this proton is most electronic most acidic due to the presence of this adjacent acyl group. Okay, so it leads to the formation of this type of ketene. Okay, then after that there will be it this ketene will be rearranged. Due to this rearrangement, it forms this product as the major product. So option 4 is the correct option. Next, and the last problem is the major product formed in the following reaction. Let's see. Here the substrate is this one. This is the oxazolidinone. This is known as the oxazolidinone, which is it is used in the asymmetric synthesis of in the of aldol condensation reactions also. So first is they are given this uh, this oxazolidinone, and this proton is the most acidic proton due to this presence of this adjacent carbonyl group. Okay. So due to the presence of this they are giving this reagent, that is triethylamine abstract this proton, and it leads to the formation of the enolate. Okay, and this O minus will they are giving this BO2 BOTF. It will then O negative attack on this boron, so to form this BOB BO2 and CH. Here it leads to the formation of the Z enolate. Upon the then after this condensation, aldol condensation of this benzaldehyde with this enolate, it leads to the syn product, because the because Z enolate gives the syn product, and E enolate gives the anti product. Here the addition will be take place from the uh, below the plane, because the presence of the hindered isopropyl group here. Uh, Here hindered isopropyl groups above the wedge. Uh, the benzaldehyde attack on the of the benzaldehyde will occurs from the below the plane. So after this, hydrolysis of this one will leads to the formation will leads to the uh, here hydroxyl group will attack on this and it leads to the formation of this carboxylic acid and CH. Here after rest of the structure will comes and this oxazolidinone will be released. So so our major product will be this one. So the option 2 is the correct option. If you have any doubt, then put it on the comment section. If you like this video, then please like and subscribe. Bye.